Hello everyone. In the last video we have solved up to question number 10th. Now this video we are going to start from question number 11th. Now over here the function is given as x minus a cos of 1 upon x minus a, and in question we are asked the continuity of this function at point A. Now if you'll check question number 11 and 10, these two questions are of similar type. Now we have to keep the same approach as we have done in question number 10th. So in this case also, if x tends to a, then x minus a will tends to 0, and 1 upon x minus a will tends to some infinity, and we know that cos is a function whose range is in between of -1 to 1. So that means if x minus a tends to 0, then this whole value is going to give us some constant term. Hence in this case, when x tends to a, then this expression will give me 0, and this whole expression is going to give us k. So 0 into k will give us 0, and this is already given in the question that the value of function at point 0 is 0. Hence limiting value and the function's value at that particular point, that means at 0, are same. Hence function is continuous at x is equal to a. Now question number 12. Now if you'll see in question number 12, they have defined the question in this way, that if x is equal to 0, then the value of function is 0. But if the value of x, when x is not equal to 0, then this is the function. Now to understand such kind of problem, what we have to do, we have to draw the question on number line. Now we can see in this function we are given one special type of function, and this function is known as mod function, and we should know what is the significance of mod. So if x is less than 0, that means whenever there is a negative term in mod, then mod makes that negative term as positive. So this is how our mod function work. If x is less than 0, then mod x will open as minus x. If x is greater than or equal to 0, then mod x will remain or will open as x itself. So now we can see 0, and from the left hand side in this interval I know the values are going to be negative, because from 0 to left hand side this whole region is the negative part and this region is the positive part. So in this case the mod will open as with minus x, and this x and x will get cancelled out. So in this interval my function is going to be only -1. But in this positive region this mod is going to open as x itself. So x and x will cancel out, and this will give me 1. Now let's check the continuity of this function. So first we'll calculate the left hand limit. So x tends to 0 from the left hand side. As we can see in this number line, if I approach 0 from the left hand side, then my function remains -1. So value of function is -1, and hence by applying the limiting, still this is going to same. And from the right hand side, if x tends to 0, now we can see if x tends to 0 from right hand side, we get function as 1. So right hand limit is 1. Now clearly it shows that left hand limit and right hand limit, this both the limits are not equal to each other, hence limit does not exist and function is discontinuous over here. Now question number 12. This is also the same kind of problem as we have solved in question number 12a. Now let's describe this problem on number line. So as we can see, if the value of x is less than 0, then mod is going to open as -x, and this will get cancelled out, will give out only -1. If the value of x is greater than 0, then this is already given in the question, this will remain as -1. Now let's calculate the left hand limit. So left hand limit of f of x is giving us -1, and the right hand limit giving us as -1. Hence function is continuous. Both the limit are equal to each other, therefore limit exists, and simultaneously this is given us the value of function at point 0 is -1. Hence function is continuous. Now in question number 13. In this question we have come across some trigonometric functions. Okay. First of all, what we have to do, we have to define the function on number line. As we can see, when x is equal to 0, then the value of the function is 2/3. This is already given in the question. So when the value of x is in this region, then we know this is the negative part, and hence we are taking minus over here, because whatever value we are going to take in this region, it will be negative. And in this case function is going to remain as it is. This is just a basic thing which we have to understand. If we are able to understand this part, the defining the function on number line, then the continuity question becomes easiest one and can be solved within the fraction of time. Now let's go for the left hand limit. X tends to 0 but from the left hand side, that means from this side. If 0 is approached from this side, you can see the function is this. So tan of minus 2x upon minus 3x. Now we know tan of minus theta is minus tan theta. So minus and minus will cancel out, and tan 2x upon 3x will remain as it is. Now in this case we know one standard result which we have studied in the chapter limit, that limit x tends to 0, tan x upon x is equal to 1. That means the angle, that is 2x over here, it should be in the denominator also. So we have to balance. So this 3 I have written over here, and I have multiplied and divided by 2 to balance this. So this expression is going to be 1, and finally we'll get 2/3. So this is left hand limit. Now we have to calculate the right hand limit. That means when 0 will be approached from the right hand side, then function is going to be this. This going to remain as it is because this is in positive region. So right hand limit, again we have to do the same thing what we have done for left hand limit. Bring this 3 over here and balance by 2, because tan of this is 2x. So whatever written over here with the 10 has to be in the denominator. Then only this is going to form the standard form and will give us result as 1. So 2/3 is the right hand limit, and this is already given in the question that function's value at point 0 is 2/3, and hence left hand limit, right hand limit both are equal to the function's values at particular